Let's start with the least likely and work our way towards the most terrifying one on the list. Threat number 1, heat death of the universe. There's a rule in physics that says disorder in a closed system always increases over time. The universe is a closed system, which sounds simple enough until you actually think about what that means. Over an almost incomprehensibly long stretch of time, all the energy in the universe gradually spreads out and equalizes. Stars burn through their fuel and go dark one by one. Black holes slowly evaporate, and that process alone takes longer than the current age of the universe raised to enormous powers. Eventually, everything reaches the same temperature, just barely above absolute zero. And at that point, nothing can happen anymore. No reactions, no movement, no light, just an infinite expanse of cold, dark, evenly distributed nothing. Forever. Not a bang, not a collapse, just everything quietly running out of the ability to do anything at all. Now, the timeline here is so far beyond what language can actually handle that it almost becomes funny. The universe is currently about 13.8 billion years old. Heat death happens somewhere around 10 to the power of 100 years from now. That number is so large it doesn't have a name people actually use. And every other threat on this list, every asteroid, every supervolcano, every gamma ray burst happens in the first few seconds of that timeline if you wrote it out. It is the only threat on this list with a 100% success rate. Whatever survives, everything else doesn't survive this. Nothing does, which, depending on your mood, is either deeply upsetting or kind of a relief. Threat number 2, nearby supernova. When a star much larger than our sun runs out of fuel, it collapses. The outer layers hit the collapsing core and rebound, and the resulting explosion is so bright it can briefly outshine an entire galaxy. Hundreds of billions of stars in one galaxy, and for a few weeks, one single dying star is brighter than all of them put together. Now, if that happens close enough to Earth, within about 25 to 50 light years, you wouldn't die from the explosion itself. Because the explosion is light years away, and space is mostly empty, what you'd die from is everything that comes with it. The radiation, the cosmic rays, the slow destruction of the ozone layer playing out over months and years. By the time your sky looked even slightly wrong, the process would already be well underway, and there'd be nothing anyone could do about it. The nearest star capable of doing this sits about 150 light years away, which puts us safely outside the danger zone. Betelgeuse, the red giant in Orion's shoulder that went viral a few years back when it mysteriously dimmed, is about 700 light years away. Also fine. Probably going off within the next 100,000 years, which in astronomical terms is basically tomorrow, but in human terms is very much not your problem. The honest concern isn't any specific star we're already watching, it's the ones we haven't cataloged yet in a galaxy containing somewhere between 100 and 400 billion stars. The odds of one going off in the kill zone during your lifetime are very small. Threat number 3, gamma ray burst. Somewhere in the universe right now, a star is dying badly. When certain massive stars run out of fuel and collapse, or when two dead stars spiral into each other and merge, the result is a gamma ray burst, a focused beam of energy so intense it releases more power in a few seconds than our sun will put out across its entire 10 billion year life. Read that again if you need to. The beam is narrow, like a cosmic blowtorch firing off in a random direction. And if that direction happens to be Earth, here is exactly what happens to you. You don't feel anything at first. You don't see anything. The radiation isn't visible. It just arrives at the speed of light and immediately begins tearing through the ozone layer. Within hours, the atmosphere starts failing. UV radiation from our own sun, which the ozone layer normally blocks, now reaches the surface completely unfiltered. Everything exposed to open sky starts dying. The oceans follow. The food chain collapses from the bottom up. Some scientists actually believe this is what caused the Ordovician extinction 445 million years ago, which killed around 85% of all marine life on Earth. We can't confirm it, but the pattern fits uncomfortably well, and the part that should genuinely bother you is that you would never see it coming. No visible flash, no warning signal, no time between detection and arrival. If one fired directly at Earth right now from 3,000 light years away, you'd be going about your morning, completely unaware, until you just weren't anymore. Threat number 4, supervolcano eruption. When most people picture a volcano, they picture a mountain with lava coming out the top. That's fine. That's a normal volcano. A supervolcano doesn't look like anything from the surface. It's just ground. Completely normal looking ground sitting on top of a chamber of pressurized magma the size of a city that has been quietly building pressure for hundreds of thousands of years. Yellowstone National Park is one. The magma chamber underneath it is roughly 55 by 72 kilometers wide. The last time it fully erupted was about 640,000 years ago, and it threw around 1,000 cubic kilometers of material into the atmosphere. The Mount St. Helens eruption in 1980, the one that reshaped an entire mountainside and made international news, threw out about 1 cubic kilometer. So picture that, but 1,000 times larger, and instead instead of one mountain in Washington state, it's most of the western United States disappearing under meters of ash. And if you think being in Europe means you're watching this safely from a distance, you're not. The ash cloud and the sulfur dioxide pumped into the upper atmosphere would drop global temperatures for years. Crops fail everywhere. Supply chains collapse. The eruption itself kills a lot of people, but what comes after it kills far more. The USGS puts the annual probability of a full Yellowstone eruption at about 0.00014%, which sounds reassuring until you find out that the eruption cycle runs roughly every 600,000 to 800,000 years, and it has been 640,000 years since the last one. You don't need to do that math out loud. The math already knows what it's doing. Threat number 5, solar flare. The sun throws charged particles into space constantly. Most of the time, Earth's magnetic field deflects them, which is actually what creates the northern lights. The particles that do make it through spiral down toward the poles and light up the atmosphere. Beautiful, completely harmless, great for Instagram. But occasionally the sun releases something much larger. In 1859, one of these hit Earth directly. It's called the Carrington event. Telegraph wires caught fire. Operators got electric shocks straight through their equipment. Auroras were visible as far south as Cuba and Hawaii. Now picture that same event hitting today. Every unshielded satellite in orbit stops working immediately. GPS gone. Communications gone. Weather forecasting gone. Then the power grid goes. The transformers that run it take between 12 and 18 months to manufacture, and almost none of them are stockpiled anywhere, because nobody wanted to spend the money preparing for something that hadn't happened recently. A Lloyd's of London report estimated this would cause up to $2.6 trillion in damage in the US alone, and leave up to 40 million people without power for 2 years. And the probability of a Carrington-level event hitting Earth in any given decade sits at around 12%. That is not a remote possibility. That is just a decision we've collectively made to not think about too hard. Threat number 6, asteroid impact. 65 million years ago, a rock about 10 kilometers wide came out of nowhere and hit what is now Mexico. And you want to know what your morning would look like if that happened today. The impact itself. You wouldn't survive anywhere within thousands of kilometers. But let's say you're far enough away. First comes the shockwave, a wall of pressure moving faster than sound that flattens everything it touches. Then the sky lights up as wildfires ignite across entire continents simultaneously. Then, and this is the part that actually finishes most things off, the debris cloud. Billions of tons of vaporized rock thrown into the upper atmosphere, blocking out the sun for years. No sunlight means no crops. No crops means no food chain. Around 75% of all species on Earth died, including every single dinosaur that had spent 165 million years completely dominating this planet. And the asteroid didn't even have a plan. It just showed up. Now the good news is NASA has been tracking near-Earth objects for decades, and nothing confirmed is currently heading our way. They even successfully nudged an asteroid off course in 2022, which was genuinely one of the most impressive things we have ever done as a species, and somehow barely made the news. The less good news is we've only spotted about 40% of the rocks out there large enough to cause serious regional damage, meaning there are thousands of asteroids we haven't found yet, quietly drifting around, some of them almost certainly pointed somewhere we wouldn't enjoy. We'll probably be fine. Probably. So that's 6 ways the universe can end things. The good news is you'll almost certainly die of something completely ordinary long before any of these get the chance to become your problem.